Hello, my name is Rihards Gailitis, I will present you the results of research of long-term property assessment of disintegrated and non-disintegrated cement mortar. So first of all, the aim of this study was to determine whether or not the disintegration would regain cement activity of cement mortar, and would it improve the mechanical and long-term properties of cement mortar that has been subjected to disintegration. Disintegration is collision milling. It is considered as a more effective way of material planning. The way that we use to assess the disintegration effect to the activity regeneration of the cement was the semi-adiabatic test, or in other words, we measured the hydration temperatures of cement mortars that were setting, and long-term property assessment was done, basically assessing the shrinkage and creep strength of the cement mortars. For this purpose, all the new cement was used. All cement was meant for the cement mortars. First of all, it was sieved through sieves with 2mm holes, and afterwards, half of that cement was put through the disintegrator DESI-16C. As you can see on the bottom side, here is the disintegrated composition of the mortar, and here is non-disintegrated composition of the mortar. After all that, the test specimens were prepared, and for creep and shrinkage measurements, cylindrical specimens were prepared with the diameter of 46mm and height 190mm. And for the activity tests, the prepared compositions were put into specific containers that were then put into polystyrene holders for the measurement taking. Long-term tests, the creep tests took place into the creep lever test stands, simultaneously to the creep test, shrinkage test was done, so that the values of the specimens that were subjected to the load or creep specimens, in other words, from those results, the shrinkage can be taken off, so to get a clean creep values, and the shrinkage specimens were placed in the same environment, the same room, at the same time. The measurements were taken as the creep tests, and yeah, I'm actually at the same lab where the tests were carried out. As you can see, some of the test stands are behind me. So the results from the semi-adiabatic results, you can see that new non-disintegrated cement mortar showed significantly higher hydration temperatures. In this case, it's 25% bigger than the non-disintegrated and disintegrated old cement mortars. As for the old non-disintegrated and disintegrated cement mortars, the hydration temperatures are similar. The peak values are within 1% difference. Therefore, the disintegration doesn't bring the cement, at least activity, back. If we look into XRD spectrometry results, we can see that no amorphous compounds were detected into the test samples. So we can surely say that the old cement was placed in the environment that wouldn't have high moisture content, therefore the hydration hasn't happened for it. Furthermore, we can see that for the disintegrated specimens, the amount of alite is higher than for all the others. And basically this is because of the milling, and because of that, the specific surface of the cement particles are increased, and therefore the higher alite amount is in the composition. If we look into the compressive strength values, we can see that disintegrated cement mortar has about 30% higher compressive strength value than the non-disintegrated new cement mortar. Furthermore, the old disintegrated cement mortar shows twice as high compressive strength values as the non-disintegrated old cement mortar. So we can say that for the mechanical properties, the disintegration bears fruit. It actually improves them. If we look into complete strains from the creep test, we can see that old cement mortars, the disintegrated and non-disintegrated ones, shows similar values, and the creep for the non-disintegrated new cement mortar is about 10 to 15% less. As for the shrinkage strength, we can see that for the non-disintegrated new cement mortar, the shrinkage is a bit higher than for the non-disintegrated old and disintegrated old cement mortars. This is mainly because of the higher hydration temperature and the moisture evaporation due to the higher hydration temperatures for the new cement mortar. If we take from the complete strains out the shrinkage strains, we can see that creep strains for the mortars are almost similar to the complete strains from the creep test, and taken the all disintegrated and non-disintegrated cement mortars show similar creep strains. As for the creep strains for the new cement mortar, it is 26% less than others. But here we have to take into account that because of the different compressive strength values, the 20% of the compressive strength value that was applied to the creep test stands is different for all the cement mortars. Therefore, all of the compositions are loaded with different load, and therefore subjected to the different stresses. Therefore, to get all of the compositions to this level playing field, or in other words, to take the stress effect out of the equation, this specific creep was determined, and as you can see on the graph down from the creep strains, the specific creep is showed there, and from curvatures there we can see that the specific creep for the non-disintegrated old cement mortar is significantly higher, almost twice as high as for the non-disintegrated new and disintegrated old cement mortar, where here we can see that specific creep of non-disintegrated new and disintegrated old cement mortar is very, very similar, with a slight decrease at the later stages for the disintegrated old cement mortar. And from this, we can tell that disintegration actually bears fruit and reduces creep. Furthermore, some analyses were done, and from the same images, we can tell that disintegrated cement mortars showed much more even composition, and from the same tests, we can see that less silicon and calcium mortars are dominant for the all non-disintegrated cement mortar. As for the others, they are more dominant. So the conclusions here are that disintegration doesn't regain the cement activity in the context that it would have the same hydration and colorimetry properties as new cement mortar. The cement would in the hydration reaction, but we can see that the disintegration makes the composition of the mortar much more finer, much more consistent and even, and therefore the compressive strength can be improved. And furthermore, the specific creep can be at the same levels as the new cement mortar. Therefore, for the construction applications, it is apparent that the disintegration is a valid procedure to be used so that all cement would be applied in the construction purposes. Thank you for your attention and maybe some questions.